This is episode 605, and this is about the types of reactions. So in the unit balancing equations, we're going to talk about how to actually determine which type of reaction we have. So for the sake of saving a little bit of time, I've gone ahead and filled these in. If you'll just kind of pause and write these down, or as I talk about them very quickly. In an equation, a lot of times you're going to see the state of matter. And so there's three states of matter. You've got a solid, a liquid, and a gas. You'll see those in parentheses. And then if you have an AQ, that means aqueous. And an aqueous solution is one that's dissolved in water. So if you'll pause for just a minute and fill that in, and then we'll go to the next one. When you talk about elements that are at room temperature, most of your elements on the periodic table are solids. So all metals are solids except for mercury, which is a liquid. It's the only liquid solid. Most nonmetals are gases, with the exception of bromine is the only liquid. So you actually have two liquids on the periodic table at room temperature. And then the solids are carbon, sulfur, and I've got them listed right here. Carbon, sulfur, phosphorus, tellurium, astatine, and selenium. So those are all of the nonmetals that are solids. All of the metalloids that are on the stair step, those are solids. And then when you're looking at compounds, if something is covalent, it's going to be a liquid unless it's stated otherwise. And if something is ionic, it will be a solid unless stated otherwise. So how do you use these in an equation? Well, if you look at this, it says when heated, solid mercury 2 oxide yields mercury and gas, oxygen gas. So to write this equation out, we would write solid mercury oxide, mercury and oxygen. This is a -2, this is a +2, so it's 1 to 1. And it says this is a solid, so we're going to put a solid in a little subscript S in parentheses. And when it's heated, there's our arrow. And for heat, we're going to put a triangle. So that means heat. It yields mercury, which is Hg. Now, mercury is a liquid, so you really don't have to put a symbol for it. And oxygen gas. Oxygen is a diatomic, so you need to put a 2. Just for the sake of making sure we know how to use all these, I'm going to go ahead and put liquid for that and gas for that. So the proper way to write this equation would be this way. Now, if we balance it, we have 2 oxygens here, and we only have 1 over here. So we need to put a 2 in front of this, which means we need to put a 2 in front of that. So there is a balanced equation using the states of matter. Okay, now there are 5 different types of equations that we're going to talk about, and the first one is a synthesis reaction. And synthesis means to make something. So when you are synthesizing, you're making things. And so this is when you have 2 or more substances combined to form a more complex substance. And the important part about this is it's A plus B. These could be compounds or elements, but you only have one product. So you only have one thing on the right. You only have one thing on the right side of your equation. An example would be iron plus sulfur, which is also a solid, can produce iron sulfide, which is a solid. Or you could have water plus SO3, which is a gas, so you could bubble this gas into the water, and you would end up with sulfuric acid, which is an aqueous solution. Acids are always aqueous. So that's how you would fill that in. And this is balanced, and this one's balanced. So synthesis is the very first type. The second type is a decomposition reaction. And in a decomposition reaction, it's the reverse of a synthesis. So you have a single substance that is broken down into 2 or more simpler substances. And an example, this would be AB yields A plus B. An example would be that water breaks down into hydrogen and oxygen. We'll balance that. And an example would be that mercury oxide is decomposed with heat. So we're going to put a triangle up there to produce 2 mercuries as a liquid and oxygen as a gas. And a gas could be, you could do that because it's going to bubble out of there and give off a gas. So there's your first 2 types, synthesis and decomposition. For a single replacement reaction, what happens is a free element, which means it's not a compound, replaces a less active element in a compound. So what it would look like is, here's the free element, here's the compound, and A is going to replace B. It kind of jumps in there and kicks it off. So you end up with B by itself, and then A joins Y as the compound. And it's really important that you know that it's the less active compound is the one that gets kicked off. So in order for this to happen, B has to be less reactive than A. And you know that by looking at this table. Let's see. If you look at this graphic, it's got the series of activity, and this is the most reactive. This is the least reactive down here. So in order to replace it, it has to be higher on the chart. If you look at this example, zinc is going to react with hydrochloric acid. And I'll tell you what, I'm just going to do the skeleton equation, not the balanced one. We're just going to do hydrochloric acid and zinc chloride is a product, and hydrogen gas. So what's happening is zinc and hydrogen are switching places. In order for this to happen, zinc has to be more active than hydrogen. So you look on your list and you find zinc, which is right here, and you find hydrogen, which is right here. Zinc is more active than hydrogen, so it will replace it in the equation. So this equation would occur. And then we could do aluminum with copper chloride. And aluminum would trade places with copper. The metals switch places. So we'd have copper by itself and aluminum chloride. The only way this is going to take place is if aluminum is higher on the chart than copper. So find aluminum, which is right here, and find copper, which is down here. So aluminum is more reactive than copper, which means it will take the place of copper. If you'll notice, the things that we make jewelry out of that are down here on the bottom, silver and gold, these are the least reactive because you don't want them to react with your skin and turn your skin green. A lot of cheap jewelry has nickel in it, and nickel will react and turn your skin green because it's more reactive than these 2 metals down at the bottom. Another example would be copper and magnesium. So I want you to go through and decide if this reaction is going to happen. This would be magnesium plus copper chloride. And I want you to decide if that is going to happen. So an activity series is an arrangement of elements in their order of tendency to react. Okay, so that takes us through the first 3 types of reactions. Now let's look at the last 2, which is double replacement. And single replacement, one thing reacted and replaced the other thing. And with a double replacement, 2 things need to replace each other. So for a double replacement, the elements of reacting compounds replace each other. So in this one, you need to have 2 compounds. This normally takes place in an aqueous solution. And these are also called metathesis reactions. So if we have AX and BY, these are two compounds, what's going to happen is my A and B are going to switch places and take each other's place in the compounds. So we would have AY and BX. Now, take a second and look at how that works. The A's and the B's are the metals, so they need to be at the beginning. So the A is going to go over here and the B is going to go over here. An example would be if we had potassium iodide and lead nitrate, and that's going to react to give us PBI and KNO3. So basically they've just switched places with this first element. In these types of reactions, sometimes you end up with a precipitate, and that is an insoluble solid. And you have a chart in your section 1, your information section, that has a solutions chart, which will tell you if things are soluble or not. And they may be represented in the equation by an S or by an arrow down. And the reason we use an arrow down, we use an arrow up for gas, we use an arrow down for precipitate. And the reason is because when something becomes a solid, it sinks to the bottom of your container. So an example of this would be AgNO3 plus my NaCl, and my Ag and my N are going to switch places. So I'm going to have AgCl and NaNO3, and this is a solid, and I would know that by looking at my solubility chart to see if it was a solid or not. Alright, so then the last type of equation or reaction that we need to cover is a combustion reaction. And in a combustion reaction, these are the ones that look kind of cool because these are the ones that involve fire. So the combustion reaction involves the reaction of a substance with oxygen, and we usually just call that burning. Okay, so if it is a complete combustion, of a hydrocarbon means it just has hydrogen and carbon, then it is going to produce CO2 as a gas and H2O as a gas. So it produces the same two products all the time. This would be CO2 and H2O. This would be CO2 and H2O. And if this is going to combust, we would do O2, and then this would be CO2 and H2O. So we'll work on those some more in class and work on balancing those. But those are your 5 types of reactions, and we will be looking at different reactions and classifying them as one of these 5 types of reactions. Okay, see you in class.